I think it's unfair to say that everybody who works in cosmology believes in the multiverse. It's still treated as a hypothesis, but it is certainly a hypothesis that more and more people are talking about. And in terms of the papers that are coming out and the talks at conferences, a larger and larger fraction are devoted to cosmology based on the idea of the multiverse.
And what do you attribute that to?
What I think I attribute it to is the mystery of the cosmological constant, which we interpret as indication of energy density of the vacuum, non-zero energy density of just empty space. Now, from the point of view of particle physics, that's not exactly a surprise that it exists, because from the point of view of modern particle physics, the vacuum really is a very complicated state. It's not at all empty the way people used to think. There are quantum fluctuations all the time, particles that appear and disappear back into the vacuum. And now, with the discovery of the Higgs particle, we even have very firm evidence that there's a field in nature which has a non-zero value in the vacuum on average. So the vacuum is complicated, and we expect it to have probably a non-zero energy density. The problem, though, is that when we try to estimate what that energy density might be, we miss by a fantastic factor, a factor of like 10 to the 120, one with 120 decimal zeros after it. Fantastic factor. So it's a big mystery why the energy density of the vacuum is so incredibly low compared to what we might expect.
And theoretically, it has to be somewhere in that range in order to allow what we see to occur with the formation of galaxies and stars and planets and life as we know it.
That's right. That's right. For life to evolve,